We're not given in terms of pi, right? But you should imagine what that angle is, working from what you know what 1 radians is equal to. Does that make sense to you? Just before we change the other one from degrees, your specimen paper, there is the cover page. Go to the cover page of your specimen paper, please. Go to the cover page of your specimen paper. It's very important. So you are not going to be asked to prove these things. You will be asked to work with them, okay? You should not forget. This is also the cover page on high level, but anyway, what I want to get is, there is a third bullet point from the bottom. If the degree of accuracy is not specified in the question, and if the answer is not exact, now answers in degrees will never be exact. I mean, in pi radians will never be exact because the nature of pi being an irrational number. Give the answer to 3 significant figures. However, there is an important thing. Give answers for angle sizes to 1 decimal place. Angle sizes, 1 decimal place. For pi, either use your calculated value or you may use 3.142 if you don't want to use the value of pi. 3.142 is a terminating decimal, but will give you more or less the same because it has got up to so many places after decimal point. The answer was going to be more or less the same. In higher level or in AS level, we penalize you for premature rounding. We subtract marks. PA, premature accuracy. That means when you are going and you cut, you say pi, you use maybe 3.14. That's the wrong value because it's not part of the instruction. Or you then go and round answers just because you're lazy, you use that rounded answer for the next part and for the next part, but that wasn't the final answer supposed to be. You're going to lose marks for that. So we must be very careful that you understand this formula. So angles can be given in radians as well as degrees. Now, let's quickly now go back, change the mode of your calculator to degree. So that the display now is in degrees. That means anything we're going to input now is going to give us an answer in terms of degrees. Okay? So when you want to change 3 radians to degrees, you follow? So you can press 3, go change it in the answer, but that 3 is what? Radians, what is the number for radians? 2 or a 3? It's a 2. When you press equal to, what do you get? 171.9, more or less, right? If you give it to 1 decimal place. Does that make sense to you? Does that make sense to you? So when you want to change the answer from radians to degree mode, your display on the calculator should be in the mode that you want the answer to be in. That's the only thing that is important for you to remember. It's something that a lot of students struggle with. You understand? They go like, oh, how do I go again? What DRG and so on. But also, you should do a very quick reality check with yourself then. 1 radians is about 57.3. 2 radians should be that. So you should have an idea. So if you were supposed to change 5 radians, then quickly say, what? Wait a minute, I forgot how to change the mode. Because it's very easy to do that. Then you quickly multiply that 5 times 57 point there. So you know, okay, this is what I'm supposed to get. So maybe I have done something wrong. I repeat, the mode should correspond with the angle measure that you're looking for. You understand that? If you're looking for an angle measure in degrees, then the display on your calculator should be in degree mode. Does that make sense to you? And subsequently, the truth is the same for radians. If you're looking for the answers in radians, that means you're now converting degrees to radians, the mode, the display on your calculator should be in radian mode. That's all. Okay? So once you have it like that, there is no problem. So before we look at special angles, we don't have to multiply times 180 upon pi. Pi is 180. Alright? Small video for you just to have a look and see how that goes. And we are going to use that to calculate now an angle, sector angle, using radians. And I'm going to use the same using degrees, so you can see that you should get the same answer. You follow what I'm saying? Alright? And also using for a part of the circumference, which is an arc length, same thing. And then we just bring in a diagram, and the diagram could be anything like, let's suppose a right angle triangle, and let's suppose maybe this goes up to there, and this is shaded, and I would want the area of the shaded part. With some values given to you, obviously you have to consider so many things. Alright, find the area of the triangle, minus the area of the sector, that gives you the shaded part. You follow what I mean? Alright, we'll put in stuff like that. Okay? We are also going to then have to know our previous formula to find the sine rule, the cosine rule, as well as the area of a non-90 degree triangle. You still remember that formula is? In fact, it's right there. Half AB times the sine of C. 60 degrees, or whatever the sine of that particular area is. The area formula for a triangle is a half AB. Yeah? So you take the actual triangle, you have AB, you have C. This angle here is C, always opposite that angle, right? Whatever this angle is, multiply these two sides, half of that, times the sine of this. And when you use the sine, make sure your calculator is in degree mode. Okay? Because otherwise you're going to get a totally different answer. Unless you change that angle here to radians. You follow? So you have to be careful. Because you know that formula to work for degrees, but angles may not always be given to you in degrees. So that comes in handy, the cosine rule comes in handy, as well as the sine rule comes in handy for the stuff that we're going to do today. Is that fine? So far so good. Before we look at special angles, we're going to draw a circle and we're going to see some nice special angles there, odd ones, even ones and stuff like that. But the idea here is you should have a general idea of what the angle measure is, more or less where it is, right? If I ask you what is 8 radians, well, quickly 8 times 57, so I'm dealing with a very big number, right? 400 and something. That means I have gone twice around. 400 degrees is about 360 degrees with some 40 degrees there. Do you follow what I'm saying? So you should have to consider that. We can talk about angles that are bigger than 360 degrees. All right? We're going to do negative angles. We're going to do double angles and stuff like that. Okay? It's very important that you get it. Okay, you can stop this. I did not watch that thing for many years, so I hope it's one of the right ones. I was trying to check before you come.